time of digital clocks, various timepieces were used to help people tell time. Such pieces include sundials, water clocks, and hourglasses. The standard clock face we use today uses a shorter hour hand and a longer minute hand to tell the time on a circular dial of 12 hours. The modern clock face was standardized during the Industrial Revolution, but before that there were many other designs that used 6, 8, 10, and 24-hour designs. The French tried to create a 10-hour clock face relating to the metric system, which has base 10 during the French Revolution. It didn't work. Italians in the 18th century tried to make a 6-hour clock work, but it used too much power. Thus we have the 12-hour clock face and 24-hour clock face used by many around the world today. Let's explore some of the mathematical reasons why a 12-hour clock face is more practical than some of the others invented throughout history. Alright, so why 12 on a clock? Why use a 12-hour clock in the first place? So we have 24 hours in one day. So we've got, 12 a.m. times and we've got 12 p.m. times. So 12 there. We can split it in half. We have, in each of those hours, we have 60 minutes. So 60 and 12 is a factor of 60, which works out really nicely because 12 times 5 gives you 60. We also have 60 seconds in a minute. So there's a little second, little 60, the kind of little extra hand that goes around a clock. But we're going to focus right now on the hours and the minutes. So 60 is an awesome number because we have 12. So we have the 12 times 5. Well, each one of those numbers on a clock gives you little 5-minute intervals. So if we were trying to figure out, the minute hand's on the 1, what does that mean? Well, okay, so we have for 5 minutes because 1 times 5 is 5. What if it's on the 6? 5 times 6 gives us 30. So each one of those we can multiply by 5 until we get to 12, and 12 times 5 is 60, so when you go all the way around, there's our 60 seconds or 60 minutes. 60 is also really great in terms of if we say a quarter past, or a quarter till. Okay, so that's 15 minutes dealing with the 60. So if we're looking at a clock and it's cut into quarters, then we have, if we're at the 3 times 5 is 15, we know that the 15 out of the 60, there's going to be a quarter. Well, it's also a quarter is we 3 out of 12. So we have a whole bunch of equivalent fractions happening. If somebody says half past or half till, typically we don't say half till, but you start going around, okay, well 6 out of 12, 30 out of 60. There's all these different number relationships and equivalent fractions that happen by using 12. So no matter what, trying to read a clock, trying to figure out the factors of 60, which also work out just really nicely with a clock, 12 just seems to be the easier set of numbers to work with. So, question I have for you, just to think about, I do not have the answer. But if you think about it, midnight, 12 a.m. is where it starts. But then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But then as soon as we hit 12 again, it's like it hits the reset. Curious, why doesn't it start at 1 and go to 12 and then switch over? Question to ponder. But a project I have for you, if you haven't already looked at it, is you are going to create a math clock. So if you go in the document section that's connected with this video, I want you to create a clock. So I've already got a blank template for you. It's got 12 spaces all the way around. But rather than just having the numbers 1, 2, 3, 4, all the way to 12, I want you to come up with numeric expressions that are going to equal each of the hour numbers, the numbers on the face of the clock. So for example, I have this really awesome math clock. This is just the box right now. But if you look here, it's hard to do this, 6 times 2. Well, that equals 12, but nowhere does it say 12 that's actually on here. Okay. Same thing if you have, for 1 o'clock, you have the 102,413 minus 102,412. Well, if you do that subtraction, you have 1. So I want you to come up with fun numeric expressions that are going to equal each of the numbers on the face of the clock. Be as creative as you can. Use exponents, square roots, anything you can think of. Just make sure that when you go to simplify that numeric expression, it equals each of the numbers. Once you've done that, take a picture. You can email it to me, post it in the comments of this video, anything that you want to do, but have fun, be creative, learn some things about clocks. Okay, I will see you guys next week.